Given this equation, square root of a squared plus b squared equals 613, wherein a and b are both natural numbers, then our goal in this question is to find the value, the numerical value of a plus b. Pause the video right now and see if you can answer this question. And if you're done, post your answer in the comment section down below. Now, let's see if you got the correct answer. So, given this equation, square root of a squared plus b squared equals 613, wherein a and b are both natural numbers, then our goal in this question is to find the value, the numerical value of a plus b. Now, seeing this equation, if we square on both sides, we have a squared plus b squared equals 613 squared. Now, this reminds me of a right triangle with a side length of a, b, and 613. Because a and b are both natural numbers, so this value a and b can be the side length of this right triangle. And also, since the hypotenuse is an odd number, it reminds me of another Pythagorean identity when one leg is an odd number. Of course, when one leg is an odd number, the hypotenuse is also an odd number. So we have, if one leg is odd, we can use this pattern. This n is odd. So the other leg, the other side length of this right triangle is n squared minus 1 over 2, the other leg, and the hypotenuse is n squared plus 1 over 2. Now, let's say, for example, if n is equal to 3. So we have the other leg as 3 squared minus 1 over 2, and the hypotenuse 3 squared plus 1 over 2. Now, 3 squared minus 1 over 2 is 9 minus 1 over 2, or simply equal to 4. Now, 3 squared is 9 plus 1 is 10. 10 divided by 2 is 5. So we know 3, 4, 5 is a Pythagorean triple. Now, another example, if n is 7, why not? So the other leg is just 7 squared minus 1 over 2. We have 49 minus 1 is 48 divided by 2 is 24. And the hypotenuse, 7 squared is 49 plus 1, 50 divided by 2 equals 25. So we have a Pythagorean triple, 7, 24, 25. So using this pattern, using this concept, we can now solve for the value of a and b. What we're going to do is to let n squared plus 1 over 2 be equal to the hypotenuse, which is 613. Now, let's solve for the value of n. First, let's multiply both sides by 2. So n squared plus 1 equals 1,226. Subtract 1 on both sides. We have 1,225. Get the square root on both sides. We have n equals square root of 1,225. Of course, n here is a positive number. Now, square root of 1,225 is just 35. So, either a or b can be 35. So, n equals 35. So, the other leg is 35 squared minus 1 over 2, or simply equal to 612. And of course, the hypotenuse, 35 squared plus 1 over 2, or 613. Now, we have a right triangle with this side length, 35, 612, and 613. Now, we can now solve for the value of a plus b, which is the side length of our right triangle. And it's equivalent to 35 plus 612. And 35 plus 612, this will give us 647. And this is our answer to this question. Therefore, given this equation, square root of a squared plus b squared equals 613, where a and b are both natural numbers, then the numerical value of a plus b is 647. And as always, we are done.